Hey guys, how's it going? In today's video, we'll be talking about proof by contradiction. In the last video, we talked about proof by contraposition. So this is just an added part to that. So the first example, it says prove root 2 is irrational. And then the second example is related to the one in the previous video, is if 5n plus 3 is odd, then n is even. So we need to prove that. So we'll start with A. In this case is the first thing I will do to solve this is, so we'll go A and B. So A, root 2 is irrational. Assume for a contradiction that root 2 is rational. In this case, so we'll go, so root 2 is irrational. So we'll let root 2 equal to P upon Q. For integers P and Q, where both P and Q have common factors of 1, and P and Q are relatively prime. Also, Q cannot equal to 0, or else it's undefined. Next step would be square both sides, so 2 equals to P squared upon Q squared in this case. Rearrange, we then get 2q squared equals to p squared in this case. So from this, we can figure out that p squared is divisible by 2. Divisible by 2. So we've got that if p squared is divisible by 2, then p is also divisible by 2. So we can then denote p equals to 2m in this case, m being a variable for some integer m, sorry. Again, substitute this into this equation right here. So we then get 4m squared equals to 2q squared. So 2m squared equals to q squared. Again, if q squared is divisible by 2, then q is also divisible by 2. Divisible by 2. This then gives us a contradiction to the initial assumption that we made that p and q have no common factors other than 1. Hence proves that root 2 is not rational, because p and q have factors of 2, but we developed that p and q in our original assumption was that p and q have only factors of 1. So this then proves that it's fake and it's false, hence proves that root 2 is not rational. It is irrational. It is irrational. Irrational in this case. Now we'll go on to B. Again, for question B, we do the same thing. We assume that 5n plus 3 is odd and n is odd. In this case, since n is odd, n equals to 2k plus 1. 5n plus 3 equals to 5 brackets 2k plus 1 plus 3. Get the same thing. We get 10k plus 5 plus 3. 10k plus 8. Which equals to 2 brackets 5k plus 4. Since 5k plus 4 is an integer, then we know that since 5k plus 4 is an integer, then we know that 5k plus 1 is even, Hence we know that it can't be odd and even at the same time. Be odd and even at the same time. Therefore, the initial assumption is false. Initial assumption is false, hence contradicting itself. For contradiction. So that is how you do these two questions by contradiction, right?